Pluto was supposed to be irrelevant, a frozen relic at the edge of the solar system that scientists once told us to forget. But now, NASA has just uncovered something on this distant world that changes everything. What New Horizons captured out there wasn't a barren ball of ice. It was a vibrant, active, and utterly mysterious world that defied every expectation. And the deeper NASA looked, the stranger Pluto became. For decades, Pluto lived in a strange space between myth and science. It was the mysterious ninth planet, tiny, distant, and barely understood. Yet it held a special place in our imagination. Then in 2006, everything changed. Scientists redefined what a planet truly was, and Pluto suddenly failed the test. It wasn't massive enough. It wasn't dominant enough. And just like that, the world was told to move on and accept that Pluto was no longer a planet at all. But the truth was far more complex, and the people making these decisions underestimated how extraordinary Pluto actually is. The demotion felt abrupt, almost unfair, but it wasn't driven by conspiracy or arrogance. It was the result of astronomy evolving. Back in the 1800s, when telescopes became powerful enough to spot distant objects, astronomers discovered new bodies at a rapid pace. For a brief moment, the solar system ballooned to nearly 20 planets simply because scientists labeled nearly anything sizable and unfamiliar as a new member of the planetary family. Eventually, criteria had to be established. A planet needed to orbit the sun directly. It had to be unique in its region of space, and it needed to stand apart from the countless asteroids, comets, and fragments scattered across the cosmos. In 1930, when Clyde Tombaugh spotted a faint dot moving beyond Neptune, it appeared to meet every requirement. Pluto was welcomed as the long-anticipated Planet X. But as technology advanced, that certainty faded. We soon realized Pluto was just one object among many in a vast icy wilderness called the Kuiper Belt, a sprawling ring of ancient debris that never formed into full planets. Pluto wasn't alone. It wasn't even the largest. It was simply the brightest, reflecting sunlight so efficiently that it appeared much bigger than it truly was. And according to the updated definition of 2006, a planet had to clear its orbit of other bodies. Pluto couldn't. It shared its region with countless neighbors, meaning it could no longer claim the title it had held for 76 years. Yet losing the label didn't make Pluto less fascinating. If anything, it made scientists more determined to uncover its secrets. In the same year, Pluto was stripped of its identity. NASA launched a spacecraft that would ultimately reveal just how wrong we were about this forgotten world. The probe was called New Horizons, a symbolic name for a mission that would push human understanding to its limits. The challenge was distance. Reaching Pluto meant traveling billions of kilometers into deep space. So engineers strapped the lightweight New Horizons probe onto an Atlas V rocket with 5 solid boosters, giving it one of the most powerful launches ever recorded. Within 9 hours, it passed the moon. Within a year, it reached Jupiter. And with a gravity assist, it slingshotted toward the unknown. Pluto's downfall as a planet was only the beginning. What New Horizons discovered next would rewrite everything we thought we understood. After nearly a decade of silent flight through the outer solar system, New Horizons was finally closing in on its target. Pluto, once a blurry speck of light in even the most powerful telescopes, now appeared as 2 faint points growing brighter with every passing day. One was Pluto itself. The other was its largest moon, Charon, a companion so massive relative to Pluto that the 2 bodies don't orbit one another in the traditional sense. Instead, they dance around a shared center of gravity, suspended in empty space, giving astronomers the impression of a strange cosmic duet. This unusual relationship hinted that Pluto might not be the simple frozen relic many assumed it to be. As New Horizons drew closer, the spacecraft began sending back preliminary images. They were crude at first, low-resolution snapshots showing little more than patches of light and shadow. But even these early glimpses revealed something surprising. Pluto wasn't uniformly gray or bland. There were differences in brightness, differences in tone, subtle irregularities that hinted at a world with unexpected diversity. Something unusual was waiting beneath that icy surface. Charon, too, showed signs of complexity. Half the size of Pluto and orbiting at a distance of only 20,000 kilometers, it was locked in perfect synchrony with its partner. Just as the Moon always shows Earth the same face, Charon always shows Pluto the same hemisphere. But Pluto is also locked to Charon, meaning that if you were standing on one side of Pluto, Charon would hang motionless in the same exact place in the sky, never rising, never setting. And if you stood on the far side, you'd never see Charon at all. This strange gravitational balance suggested a violent past, possibly a collision so intense that it shook both worlds into their current orbits. But even these orbital mysteries paled in comparison to what was coming next. As New Horizons moved within range, its high-resolution cameras activated, capturing the first ever close-up images of Pluto's surface. And the world that emerged defied every expectation. Pluto wasn't a dull, monotone sphere. It was a vibrant mosaic of colors and textures, deep reds, pale blues, bright patches of white, golden hues, and stretches of burnt orange. The most striking feature was impossible to miss: a giant heart-shaped region carved across the surface. One side was smooth and unmarked, a flat plain of pale ice. The other side contained ridges, pits, and mysterious variation. It was immediately clear this world was alive in ways no one imagined. The smooth half of the heart, later named Sputnik Planitia, stunned scientists. Its surface completely lacked impact craters. In a solar system filled with ancient scars left by billions of years of collisions, such smoothness could mean only one thing: Pluto's surface was constantly renewing itself. Something was erasing the craters, something geologically active. Even more astonishing were the signs of flowing glaciers. Along the edges of Sputnik Planitia, patterns emerged. Glacial lines descending from rugged highlands into the frozen plains. But these weren't glaciers made of water. At Pluto's frigid temperature of minus 229 degrees Celsius, water ice is as hard as rock. Instead, the glaciers were composed of nitrogen ice, a substance that behaves very differently in extreme cold. Under Pluto's conditions, nitrogen flows, shifts, and reshapes the land. As New Horizons zoomed in further, it revealed polygon-shaped cells across the surface of the ice plain, evidence of convection, where heat from below rises upward, melts the ice, and sends gaseous nitrogen, forming a thin atmospheric haze above Pluto. This meant Pluto wasn't just active on the surface. Heat was rising from the inside, a shocking revelation for such a small, distant world. The deeper New Horizons looked, the clearer it became. Pluto was not the frozen fossil humanity assumed. It was something far more mysterious. New Horizons had revealed that Pluto's icy plains were alive with motion, but the surprises didn't stop at the surface. As the spacecraft continued collecting data, it detected something almost unbelievable. Pluto had an atmosphere, thin, fragile, and shimmering faintly above the frozen terrain. Even more remarkable, this atmosphere wasn't made of water vapor or oxygen, but of nitrogen gas rising directly from the planet's icy surface in a process called sublimation. Under Pluto's extreme cold, nitrogen transitions from solid to gas instantly, feeding a delicate haze that extends hundreds of kilometers into space. The atmospheric pressure New Horizons measured was astonishingly low, about 1 million times weaker than Earth's. Yet, despite its weakness, it was structured, layered, and constantly shifting as sunlight interacted with the surface. And because Pluto follows such a stretched, elliptical orbit, this atmosphere doesn't remain constant. When Pluto draws closer to the Sun, its surface warms just enough to intensify sublimation, creating a thicker, more dynamic sky. At certain points in its orbit, Pluto's atmospheric pressure could even reach a quarter that of Earth's, surpassing Mars in density. But Pluto's atmosphere wasn't the only thing painting it with mystery. The planet's most dramatic colors, deep reds and rusty browns, stained vast regions like the famous Cthulhu macula. These dark areas puzzled scientists until they realized they were coated with tholins, complex organic molecules formed when ultraviolet radiation breaks apart methane and carbon dioxide in Pluto's upper atmosphere. The fragments recombine into long chains, turn reddish, and eventually fall to the ground like cosmic dust. Winds and glacial movements then spread these reddish compounds across the landscape, highlighting Pluto's dynamic surface processes. Yet beneath the beauty lay something even more surprising: evidence of cryovolcanism. One massive structure right Mons towered nearly 5 kilometers high and stretched 150 kilometers across. Its shape resembled a volcanic dome, but instead of lava, it likely erupted slushy mixtures of water and methane. Only one impact crater marked its entire surface, a sign that these eruptions might have occurred not millions but relatively few geological moments ago. For a world this small and cold, active volcanism was supposed to be impossible. And still, the biggest mystery lingered beneath the surface. Pluto's convection patterns, its flowing glaciers, and its apparent volcanic features all pointed to a shocking conclusion. The dwarf planet still possessed internal heat. Somewhere below the icy crust, a vast ocean of liquid water might exist, one that had somehow remained warm for billions of years. Pluto wasn't just active, it was alive with secrets waiting to be uncovered. As New Horizons continued transmitting data back to Earth, scientists began assembling a picture of Pluto that was far more complex than anyone had imagined. Everything, from the layered atmosphere to the convecting ice plains to the volcanic domes, pointed toward one astonishing truth. Pluto wasn't simply a frozen relic drifting silently at the edge of the solar system. It had been shaped, scarred, energized, and transformed by processes that challenged our understanding of small celestial bodies. And much of that mystery traced back to one relationship: Pluto and its moon, Charon. Charon wasn't just any moon. It was enormous relative to Pluto, nearly half its size. In fact, the gravitational interaction between the two was so intense that they rotated together around a shared point in space, creating a tidal lock unlike anything else in the solar system. This bizarre orbital balance suggested something dramatic must have happened long ago. Rather than simply forming together, Pluto and Charon likely collided in the distant past. The energy released from such an impact, far greater than any volcanic process, could have reshaped both worlds, injecting heat deep into Pluto's interior and influencing every geological feature we see today. That collision might explain why Pluto's heart-shaped region lies directly opposite Charon. The impact could have redistributed mass inside Pluto, causing the entire dwarf planet to reorient itself over time. And while that heart looks peaceful and smooth, the forces that created it were anything but gentle. Yet the strangest part wasn't the collision itself. It was the implication that Pluto still retained heat billions of years later. By every standard model of planetary cooling, Pluto should have frozen solid eons ago. Small objects radiate heat more quickly than large planets, and Pluto's distance from the Sun provides no meaningful source of energy. But New Horizons showed evidence of active glaciers, convection, cryovolcanism, and resurfacing, all of which require heat. Somehow, Pluto was still warm inside. One explanation suggested internal radioactivity. Even small amounts of radioactive decay in Pluto's rocky core could provide heat, especially if the core contained significant amounts of potassium-40 or similar isotopes. Another possibility was tidal flexing. Although Pluto and Charon are tidally locked now, they might not always have been. Early variations in their orbits could have generated enormous friction, warming Pluto's interior over long periods. But these theories still couldn't fully explain the scale of the geological activity observed. The real game changer came when scientists considered something even more remarkable: a massive subsurface ocean. The patterns in Sputnik Planitia, the smooth plains lacking impact craters, and the convection cells all hinted at a layer of liquid water beneath the nitrogen ice, kept warm either by residual heat, insulating layers, or perhaps even antifreeze-like compounds such as ammonia. If such an ocean existed, it would mean Pluto wasn't just geologically active. It might also possess one of the most intriguing environments for potential life in the outer solar system. But Pluto's secrets weren't limited to its interior. Its surface was equally extraordinary. The reddish, tholin-covered region known as Cthulhu Macula stretched halfway across the dwarf planet, its color influenced by organic molecules produced through atmospheric chemistry. Winds, sublimation, and deposition cycles transported these reddish compounds over time, painting Pluto with patterns that revealed how its climate had evolved over millions of years. Then there were the ice mountains, towering peaks made not of rock, but of solid water. At Pluto's temperatures, water freezes harder than steel, creating cliffs, ridges, and rugged formations that resembled mountain ranges from Earth's most extreme regions. And in their shadows, nitrogen and methane ices slowly crept across the ground like glaciers made of alien frost. The more scientists examined Pluto, the more it became clear that it operated under rules unlike any other world we had studied. Even the atmosphere defied expectations. When New Horizons looked at Pluto during backlit conditions, it saw layers of haze, dozens of them, stacked like sheets of gauze stretching far above the surface. These layers weren't random. They indicated active weather cycles, pressure changes, and atmospheric circulation that turned Pluto into a living system despite its distance from the Sun. And then came perhaps the most bittersweet realization. These images and measurements might be the last we ever see of Pluto for generations. New Horizons' flyby was brief, only a few days of close observation before the spacecraft sped onward into the Kuiper Belt. NASA had no current plans for a return mission. Funding and priorities had shifted to other worlds closer to home: Europa, Titan, Venus, and Mars. Pluto once again was left alone in the darkness. Yet New Horizons wasn't done. It moved deeper into the Kuiper Belt, venturing into regions untouched by any other spacecraft. The discoveries it would make next, ancient bodies, strange shapes, unexpected chemistry, would continue expanding our understanding of the solar system's outer frontier. But Pluto remained its crowning accomplishment. A world dismissed, underestimated, and ultimately transformed into one of the most fascinating objects humanity has ever explored. As New Horizons left Pluto fading behind it, scientists were struck by a strange mixture of triumph and longing. The mission had accomplished what many once believed was impossible. It transformed a distant point of light into a fully realized world, vibrant, dynamic, and overflowing with mysteries. But the encounter had been fleeting. After only a brief window of close observation, the spacecraft was already racing onward, carrying with it the unanswered questions that Pluto had stirred. Still, what New Horizons delivered was nothing short of revolutionary. It proved that even the smallest and coldest worlds could be active. It revealed that glaciers flow on Pluto, that its atmosphere rises and collapses in cycles, and that towering mountains of water ice stand like frozen monuments across its surface. It showed us organic compounds sweeping across the terrain, forming colors and patterns that hinted at chemical processes still unfolding today. And perhaps most astonishingly, it provided evidence suggesting that Pluto's interior might hold a global ocean, one that has survived billions of years in a place where liquid water should be impossible. The implications were enormous. If Pluto could maintain an ocean beneath its icy shell, what other worlds could be hiding similar environments? Bodies like Triton, Eris, Sedna, and countless objects deeper in the Kuiper Belt could share the same secret: heat where none should exist, liquid where everything should freeze, and chemistry that might even allow life to spark in the unlikeliest places. New Horizons didn't just rewrite Pluto's story, it reopened the entire conversation about what it means for a world to be alive. As the spacecraft continued into the Kuiper Belt, it encountered another object, Arrokoth, a primordial remnant from the solar system's earliest days. The images revealed a snowman-shaped world untouched for billions of years, preserving the original building blocks of planets. This discovery further emphasized Pluto's uniqueness. Despite forming from the same ancient material, Pluto had evolved dramatically. It had changed, resurfaced, breathed, frozen, thawed, and reshaped itself over eons. It wasn't a relic, it was a survivor. Yet for all the excitement that Pluto generated, NASA's priorities shifted elsewhere. Missions were redirected to Europa's hidden ocean, Titan's methane lakes, Venus's unpredictable atmosphere, and Mars's ongoing climate evolution. Pluto, distant and difficult to reach, slipped quietly back into the shadows. There were no follow-up probes, no orbiters, no landers, just the single breathtaking flyby of 2015. The images New Horizons captured may be the last close-up views of Pluto in our lifetime. But even in silence, Pluto continues to inspire. It stands as a reminder that wonder still thrives at the edges of the solar system, that labels like planet or dwarf planet do nothing to diminish a world's importance, and that sometimes the most extraordinary discoveries come from places we were told not to care about. Pluto was underestimated, dismissed, and nearly forgotten. Yet when New Horizons looked closer, it found beauty, complexity, and a world that challenged everything we thought we understood. It proved that exploration is never wasted, and that curiosity will always reveal something worth knowing. And now the question becomes, what else is waiting out there in the darkness? What other worlds will surprise us? What other discoveries are hiding just beyond our reach? If you're ready to keep exploring the mysteries of the solar system, the universe, and the strange places where science and wonder collide, then subscribe to the channel and turn on notifications. Pluto was only the beginning. The next discovery might be even more unbelievable, and you won't want to miss it.